If Earth is spinning, why can't a plane simply take off, stay in the air, and let the planet rotate underneath it? It sounds like the perfect shortcut. A plane in New York wants to reach Los Angeles. Instead of flying for hours, it climbs into the sky, holds still, and waits. Earth keeps turning, the ground moves, the cities slide past. A few hours later, Los Angeles should appear below. At least, that is how it feels like it should work. But it never happens. A helicopter cannot rise above a city and watch the continent sweep away beneath it. A balloon does not launch from one country and land halfway around the world just because Earth turned. And a passenger plane does not save fuel by simply waiting for the destination to arrive. The reason is not that Earth is barely moving. Earth is moving fast. At the equator, the surface of the planet rotates at more than 1,000 miles per hour. Even far from the equator, the ground beneath your feet is still racing eastward. Right now, your house, your chair, the clouds above you, and the airport runway are all being carried around Earth's axis. So the real mystery is not why planes do not let Earth spin beneath them. The real mystery is why we do not feel that motion at all. To understand it, imagine standing inside a moving train. The train is gliding smoothly forward. You hold a small ball in your hand. If you toss the ball straight up, it does not fly backward and hit the rear wall. It rises, falls, and lands near your hand. Why? Because before you threw it, the ball was already moving forward with you, with the train, and with the air inside the train. Even though it looked still in your hand, it already had the train's forward speed. When you tossed it up, you did not erase that speed. The ball kept moving forward, while it moved upward and downward to you, inside the train. It looked like a simple vertical toss. To someone outside, it followed a curved path, moving forward the whole time. That is the key. Motion depends on what you are comparing it to. Now replace the train with Earth. Before a plane ever takes off, it is sitting on a runway that is already moving with Earth's rotation. The plane is moving. The passengers are moving. The fuel, the luggage, the engines, and the air around the airport are moving too. They do not look like they are moving, because everything nearby shares the same motion. When the plane lifts off, it does not suddenly lose Earth's rotational speed. It carries that motion with it, just like the ball in the train. The plane keeps the sideways motion it already had before takeoff. So if a plane could magically hover above the runway, it would not be hovering over a still planet from the viewpoint of space. It would still be moving eastward along with the rotating Earth. That is why the runway does not instantly vanish behind it. The plane is not being left behind by Earth. It is part of Earth's moving system. But there is another piece people often miss. The air is moving too. Earth's atmosphere is not a separate glass shell standing still while the planet spins underneath it. The atmosphere is pulled along by gravity, friction, pressure, and the motion of the planet. Near the surface, the air generally rotates with Earth. That means a plane is not flying through a motionless ocean of air while the ground races beneath it. It is flying inside air that is already moving with the planet. This is why the idea of just hovering does not work. To hover above one spot, a plane or helicopter must stay in position relative to the air and the ground around it. But that air and ground are already moving together. From the viewpoint of the airport, the aircraft can appear to hover. From the viewpoint of space, it is still racing around Earth's axis. The mistake comes from imagining Earth as a spinning ball and the sky as something outside the ball. But the sky is not outside the system. The sky is part of the system. The airplane is not escaping Earth's rotation just because its wheels leave the runway. It is still inside Earth's gravity. It is still inside Earth's atmosphere. It still carries the speed it had at takeoff. This is the same reason you can jump straight up and land in the same place. If Earth were truly spinning away beneath you while you were in the air, every jump would be dangerous. You would leap in your bedroom and land against the wall. Birds would take off from a tree and watch the forest slide away. Rain would fall in strange sideways sheets across the world. But that is not what happens, because you, the tree, the rain, the air, and the ground are all moving together. The strange part is that stillness is not always real stillness. A person sitting quietly in a chair feels motionless, but relative to Earth's axis, that person is rotating. Relative to the sun, Earth is orbiting. Relative to the galaxy, the entire solar system is moving. Stillness is local. It depends on what you are using as your reference point. From your point of view, the room is still. From space, the room is spinning. Both views can be true because motion is relative. This is where planes become especially interesting. When a plane flies from New York to Los Angeles, it really does move west relative to the ground. But it does not start from zero in space. It starts with the eastward speed of Earth's rotation at New York. To go west across the map, it must change its motion relative to the air and ground. It cannot simply cancel Earth's rotation by leaving the surface. It would need a huge force to remove its inherited eastward motion. Ordinary flight does not do that. A plane's engines push it through the air. Its wings shape airflow to create lift. Its navigation system tracks motion relative to Earth's surface. The plane's journey is not about escaping the spinning planet. It is about moving through the moving atmosphere faster, slower, or sideways compared with the ground below. This is also why flying east or west is not as simple as with Earth or against Earth. Many people imagine that flying west should be easier because the destination is rotating toward the plane. But both the plane and destination already share Earth rotational motion. What matters more in real flights is the atmosphere, especially large-scale winds like jet streams. Sometimes flying east is faster because powerful winds high in the atmosphere push planes along. Sometimes flying west takes longer because planes fight those winds. But this is not because Earth is simply sliding underneath them like a conveyor belt. It is because the air itself has patterns, currents, and speeds. Earth's rotation still matters, but in subtler ways, it helps shape global winds. It contributes to the Coriolis effect, which influences large moving systems like storms and air currents. It affects navigation, weather, and long-distance motion. But it does not allow a plane to rise into the sky and wait while the planet does the traveling. The planet, the air, and the aircraft are too connected for that. Think of standing on a giant moving walkway at an airport. You and the walkway are moving together. If you toss a coin upward, it does not shoot backward. If you jump, the walkway does not race away beneath your shoes. You keep the motion you already had. Now imagine the walkway is Earth, except much larger, smoother, and wrapped in an atmosphere that moves with it. That is closer to what is really happening. The problem is that our brains are built for everyday speeds. We understand walking, running, falling, and throwing. We do not easily imagine living on a planet rotating hundreds of miles per hour while also orbiting the sun. Because everything around us shares the motion, our senses quietly subtract it from experience. That subtraction is useful. If your brain made you feel Earth rotation every second, ordinary life would be impossible. Instead, your brain cares about changes in motion, sudden acceleration, sharp turns, falling, braking, turbulence. Those are the moments you feel. Smooth shared motion disappears. That is why a passenger on a steady flight can sip water, watch a movie, or fall asleep while traveling hundreds of miles per hour. Inside the aircraft, everything shares the plane's motion. The cup, the seat, the air, and the passenger are moving together. The same principle is happening on a planetary scale. Earth feels still because we are moving with it. A plane does not beat Earth's rotation by leaving the ground. It begins as part of that rotation, carries that motion into the sky, and then adds its own motion through the air. So the next time someone asks why planes do not simply let Earth spin beneath them, the answer is not just because physics. The answer is that they already are spinning with Earth. The runway is moving, the plane is moving, the air is moving, the destination is moving. The entire stage is in motion before the first engine even starts. A flight is not a machine escaping a spinning world. It is a machine navigating inside one. And that is the quiet twist hidden in the question. We do not live on a planet that spins beneath us. We live inside the spin.